Hi, so today's lesson's on chi-squared calculations, which is one of the statistical tests that you use in A-level biology. So the learning outcomes of today's lesson are to successfully create a null hypothesis and hypothesis, and to understand the steps involved in a chi-squared calculation to carry this out in an exam question. So, in this example, a species of moth has two varieties. One is dark-coloured and the other is light-coloured. So the biologist wants to see if there is a difference in the frequencies between dark-coloured moths and light-coloured moths in two different towns. So, firstly, you need to construct a hypothesis. So, a hypothesis is what you expect your results to show. So in this example, you could say, I hypothesize that there will be a higher frequency of dark-coloured moths than light-coloured moths in town A. Whereas your null hypothesis is saying you don't think there will be a statistical significance in the difference between the two variables. So in this case, you could say, I hypothesize that the frequency of dark-coloured moths will be the same as the frequency of light-coloured moths in town A. So you're predicting that there will be no difference in the number of moths in that town. So, moving on to the chi-squared calculation itself. So, this value here is the chi-squared value. So this is what you want to calculate. Then, this value here is equivalent to the sum of. So you're saying that the chi-squared value is equal to the sum of this fraction. So, O stands for observed. So, the observed frequency is the probabilities that you observe in the experiment. So, observed for dark-coloured moths in town A is 23. So the values here in the table are all your observed values. Then, expected frequency. So this is calculated by row total times column total divided by the overall total. So the expected frequency of dark-coloured moths in town A would be equivalent to 65 times 78 divided by 150, which is your overall total. So the degrees of freedom calculation shown here is used to determine whether your chi-squared value is significant or not. If your chi-squared value is significant, this means you can accept the hypothesis and reject the null. However, if your chi-squared value isn't significant, then you must accept the null hypothesis and reject the hypothesis. So, a chi-squared test needs you to know the critical value, which is normally given in a table within the exam question, for the probability level you're testing for, which is either 0.05 or 0.01. A chi-squared value equal to or greater than the critical value means you have a significant result and you can therefore accept the hypothesis. The next step in the chi-squared calculation is to calculate these expected results. So, by using the equation of row total times column total divided by overall total, you're able to calculate these values shown in the table. So, as I said before, the frequency of dark-coloured moths was equivalent to 65 times 78 divided by 150, which gives you a value of 33.8. The next step in a chi-squared calculation is to calculate the observed minus expected part of the calculation. So as shown in this table, this would be the observed value minus the expected value calculated previously in brackets. This value is then squared. Then you work out degrees of freedom. So degrees of freedom is the number of rows minus 1 times the number of columns minus 1. So in this case, you have two rows. You have town A, town B. So that's 2 minus 1. Then in terms of column total, you have dark colour and light colour. So essentially, it's the number of variables that you have in the rows and in the columns. So in this case, degrees of freedom is 2 minus 1 in brackets times 2 minus 1 in brackets, which is equal to 1. You then use a probability table to look up the critical value for the degrees of freedom at 1 and significant level of 0.05. So in this case, the critical value would be 3.84. To get the chi-squared value, you would add up all of these numbers here, so the 3.74, 3.5445, 2.64, and 2.86, as these are equivalent to the observed minus expected squared. Upon adding all of these up, it comes to a total of 12.69. Therefore, due to the fact that 12.69 is greater than the significance value of 3.84, it means that a significant result has been observed. This allows you to then approve the hypothesis which can now be accepted, and reject the null. So the conclusion you would draw from this chi-squared calculation is that your hypothesis is accepted, and therefore the frequency of dart moths in town A is greater than the frequency of dart moths in town B, for example, if that was your hypothesis at the start. And yeah, thank you for listening.